Welcome back. In this episode, I'll be talking about lists. Now, unlike the basic data types we talked about, lists are a little bit more complicated. It's essentially a data type that's an ordered container for information. And you just create it using square brackets and separating all of the items in your list with commas. So for example, if I wanted a list of strings, here I can say Juan, which is a string, comma, Roger, comma, Ying. And now this is a list that contains 3 different strings, okay? So you can actually create empty lists. There doesn't have to actually be anything in it if you don't want. So I can say empty list equals open square bracket, closed square bracket. Now, this list can contain basic data types. So here's an integer list that just has 1, 2, 3, 4, 5. Or it can have floats, 1.1, 1.2, 1.3. But you can also mix the data types that go into the list. 1, hello, 4.4. All of these are valid lists. Now, you can also have lists of lists. So, for example, inside my list, I can have 1, 1, 2, 1, 8, 0. And this is also a perfectly valid construct. And we'll see later how we can use lists to keep track of information when we need to know exactly where it is. I don't actually need to run this because you can see that I'm not actually printing anything. We won't see any results. Nothing's actually happening. But we can actually look at how to get information out of these lists. So here, what we should know about lists is that they always stay in the same order. So you can get information in and out really easily. And list indexes act very similar to string indexes. So here I have this int list, 1, 2, 3, 4, 5. To get the first item, I use square brackets and a 0. To get the last item, square brackets and a -1. Alternatively, I could check the length of the list and subtract 1 to get the last item in the list. To get the second to the fourth item, it's the same syntax as the strings. I can just say 1:5. That'll be second to fourth items. And if I want to actually find where an item is within the list, I don't have a find method. Instead, I have an index method. So integer list.index2, that will find me the index of wherever the integer 2 appears, which should be at index 1. So let's go ahead and run this. We can see we have 1, 5, 5, and then 2, 3, 4, 5, and then 1. These are the results of the code that I just displayed. Now, you can also change values in lists really easily. If you want to change an item at a specific index, you can just do integer list at index 3, and I'm going to set that equal to 10. I can add an item to a list using append. I can remove an item from the end of a list using .pop. Now this will also return whatever I pop off of it, but we don't need to worry about that really. You can also specify what the index of the item that you want to remove by saying .pop1. This will remove the item at index 1. And you can insert a value at a specific index with list.insert1, that is the location that you want to insert it by index, and 42, which is the value you want to put in your list. Now, I should point out that lists do have some unexpected behaviors that the basic data types don't. Some list methods will actually modify them in place, meaning that they don't need to be reassigned to a variable. So for example, pop, you can use this without having to reassign it to int list. So be aware of this, because if you're not, weird things can happen. But it shouldn't be a problem for us in this class. So I'll go ahead and run this, lists3, tab that out, enter, and we can see that it changes from, we have 1, 2, 3, 10, 5, then we add a 6, then we remove the 6, and then we remove the 2, and then we add 42. So we've changed this list in a number of different ways. We can also change strings into lists quite easily. If we look at changing to and from lists, I can actually just use the list function and stick in a variable. Here I'm sticking in this my string. And what we can see is that this will turn the string into a list of individual characters. We can also use the split function, .split, and I can split it along spaces to turn this into a list of the words in the sentence. And I can turn this back into a string with kind of weird-looking syntax. New string equals space dot join my list. Now this is a little weird and might seem a little backwards if you're familiar with other programming languages, but essentially dot join on a string will put whatever is in your list back together using that, that particular string as the dividing line. So I can say, instead of a space, I can say Chumbawamba, and I can run this, and we can see that now we have, hello, my name is Paul, all individual characters, and then hello, my name is Paul, as individual words, and then hello, Chumbawamba, my Chumbawamba name, Chumbawamba, is Chumbawamba Paul. So you can actually stick whatever you want in. I'm going to go back and change that back to a space so we can see this is what it's actually supposed to look like. Hello, my name is Paul. Okay? There are, of course, many other methods that come with strings that are just as useful for us, and I'll cover them just really quickly. This isn't comprehensive. You can go to the Python online documentation to find all of them. You can get the number of elements in the list using length. This is very similar to getting the length of a string. You can get the minimum value from a list if it has numbers in it using min. Similarly, you can get the maximum value from the list using max. You can reverse the list by using .reverse. You can sort it using .sort. And you can sort it in reverse order by saying .sort reverse equals true. I'll go ahead and run these so you can see what that looks like. And then you can see that we have 5, 1. So 5 is the number of elements in the list. 1 was the minimum value. And then you can see 4, 3, 5, 2, 1 is just that list flipped around. And then you can see 1, 2, 3, 4 is the list sorted. So there are all these methods that will let us manipulate lists to help us do the types of analyses that we want to. Now in the next episode, we're going to start talking about Boolean values. And these are the values that are going to let us start to add logic to our code that will let us start doing some cool things. So I hope you'll join us next time. Thank you.